Welcome to solverfy.
For this question, they are first wanting us to find the factor of expansion when a scuba diver is ascending from a certain depth. So for our first known for this question is the density of seawater, and that is equal to 1.04 grams per milliliter. I'm just going to quickly times this by 1,000 to get it into units of kilogram per meter cubed. So 1040 kilogram meter cubed. They also tell us that the depth is equal to 125 feet. I'm just going to change this into meters by timesing it by 0.3048 meters. So this is going to equal 38.1 meters. And our pressure is going to be equal to an atmosphere, or 1 atmosphere, which is also equal to 101,325 pascals. And we're going to be using, just so that way you know, the pascals actual units are kilogram per meter times second cubed, just because we're going to be using gravity, and gravity is equal to 9.81 meter per second squared. Alright, so for the first part of this question, we're going to want to find P1. So P1, and P1 it's going to equal the atmosphere pressure plus the pressure from the water. So we know that 1 atmosphere is 101,325 pascals. And this is also like saying the pressure of the atmosphere plus the density, gravity, and the height of the water. So then we're just going to add 1040 kilograms per meter cubed, times that by the gravity, and then times that by our depth, which is 38.1 meters. So P1 is going to equal 490036.4 pascals. So for this question, we assume that PV is constant. So we're going to be using P1 V1 over P2 V2 is constant. And this is like saying V2 over V1 is equal to P1 over P2. So P1 over P2 is what we're looking for to get the factor. So 490036.4 pascals divided by P2, which is 101,325 pascals. So the factor is 4.84, and this is the factor at which the lungs will expand from that depth. So for the second part of this equation, or for the second part of this question, they're asking us to find how far she can safely ascend from a certain depth if the expansion factor is greater than 1.5. So we know P1 is equal to the pressure of the atmosphere plus the pressure of the water, and this is equal to 490036.4 pascals. Again, we assume that V2 over V1 is equal to P1 over P2. Because it says that the expansion factor is greater than 1.5, we're going to say V2 over V1 is equal to 1.5. So P2 is equal to 490036.4 pascals divided by 1.5. So P2 is equal to 32,660.9 pascals. Alright, and then we also know that P2 is equal to the atmosphere pressure plus the density of water, gravity, and the height, and height too, since we're ascending from a certain depth. We want to see how far she can ascend safely. So P2, so that's 32,660.9 pascals is equal to 101,325 pascals plus pGh. So density, gravity, and height 2 is equal to 22,5365.9 pascals. So our height 2 is equal to this number, and we're going to divide this by our pressure, or our density, I mean, of the seawater, and we're going to times this by gravity. So our height is going to equal 22.1 meters. We want to change this into feet, so it's going to be 72.5 feet. And we want to see the height that she can ascend safely, so we want delta H, and that's equal to height 1 minus height 2. So our height 1 is 125 feet, and 72.5 feet is our second height. So 52.5 feet is how far she can safely ascend.